case, when function phi1 is equal to 0, this is solution of previous equations that I mentioned for this equation. So it's possible to solve it also and find integrals. And these integrals, we have 5 integrals in this case, and system of equations, ordinary differential equations along characteristic becomes just one equation. So, and here I want to say about second class of right side. So this is previous one. It was about right side when it was case not equal to 0, some conditions. But here we will consider so-called because phi3 is equal to 0, it will be isentropic case. So entropy is constant. And in this case, solution will be of the following form. Solution for right side, where function phi1 here, it is related through by function h, and function h satisfies trivial equation. So here, so here are some notations that are used for S1 and alpha. Alpha, it is sound speed. So then in this case, as I told, that solution will becomes isentropic. So then solution along equations along characteristics becomes the following system of equations. Actually, you can see that here rho is constant, u is constant, and p is constant along characteristic. And it is interesting to suppose it's possible to show that u plus alpha also constant along characteristics. This means that characteristics are straight lines, and with so straight this because this is constant. And also it's possible to say that rho u and p and this combination of b are constant along characteristic. And question is, maybe this is simple wave. Actually, no, it is not a simple wave. It is not a Riemann wave because B2 and B3, they are not constant along characteristic. In case of a simple wave, they will be constant. So actually, I finished to my presentation. Here I wanted to show only that it's possible also to find a group admitted, but it is not related with method of differential constraints, so I won't talk. And this is literature that I used for this type of presentation. And thank you very much for your attention. Here I want to remind you that about our conference, which will be in August 2021. Thank you very much. I'm ready for questions.
Thank you very much, Serежа, for your report. And now, please, any questions, any remarks?
No.
У меня такой вопрос, это вот все, вот это дифференциальные связи, то если много переменных, оно как бы делается или не делается, или это слишком сложно?
Okay, if it will be a number of independent variables more than 2, then in this case, it is, I don't know how to construct such kind of solutions, but there are some solutions which are described by differential constraints. For example, in gas dynamics, it is interesting that there is differential constraints which is in an evolution with system of equations. It gives relation between vertex and entropy. So, but I don't know how to construct such kind of solutions, the realization of simple waves in multi-dimensional case. Салават, я ответил?
Ну, когда многомерный, то что-то не понял.
Многомерном там сложнее. Ну, пока нет результатов. Есть такие простейшие результаты.
Ну, вот еще такой вопрос. Простые волны. Обычно это как бы дифференциальная частично инвариантное решение дефекта 1, ранга 1. То есть не то, что вот как ты говоришь, это функции, неизвестные функции там зависят между собой. А вообще говоря, это же ведь частично инвариантное решение дефекта 1 ранга 1. Ты упрощаешь вот только такие, а на самом-то деле там тьма всяких.
General definition of simple wave when functions are dependent on one function. I know that it is particular case of partial invariant solution. I agree. So partial invariant solutions.
Которые переносов и все. А есть же и для других то же самое.
Of course, I know it. But this is simple wave. I'm talking about simple wave. I'm not talking about some other conditions.
Да.
Сереж, а как устроены в обобщенных простых волнах характеристики? Они прямые?
They are not straight. So it's possible that some of them, for example, in magneto gas dynamics, as I showed, so then in one of cases they are straight, but in general they are not straight lines.
И они распространяются по неоднородному фону, получается, да?
Of course, yeah. So and non-isentropic, so они не изентропические. Да?
Понятно. Спасибо.
Hello.
Yeah,
Yep.
please.
Sir, at one point you spoke about the non-homogeneous case. So first it is like we are speaking about the homogeneous part, and how do you then bring in the non-homogeneous part in calculating the simple waves?
Actually, mostly simple waves are constructed for homogeneous equations. But like, for example, here Salavat Valevich Khabirov, he told that it's possible to construct so-called partial invariant solutions. And partial invariant solutions, they are solutions of defect 1. So it doesn't matter it is homogeneous or not homogeneous equation. So algorithm is the same. Even for constructing generalized simple waves, its algorithm is absolutely the same too, because the most important it is compatibility theory. Actually, you need to consider involutiveness of original system, of a determined system of equations. So algorithm is the same. So from method of differential constraints point of view, but mostly this assumption about relation between dependent variables. So this is given for homogeneous system of equations. In case if not homogeneous, it's necessary to consider partial invariant solutions.
Thank you.
Next questions, please.
Hello, good afternoon.
Oh, yeah. Hi, Sibu.
Yes. Hi, Sibu, and thank you so much for the presentation. I just wanted to ask, do you know at this stage, and I don't know if you've thought about it, just in terms of if you were looking at system, you know, systems, let's say, of equations where I want to get first integrals, and if you use this method of differential constraints, how would you link the, I don't know if there's a relationship, if I want to get the first integrals, how can I do that? It's actually invariance of the system. Is there a way of doing it using your approach? Like in here, if I was using symmetries, I can get the first integrals maybe by a few steps, but I'm just wondering what's the advantage in comparison, let's say if you're using group theoretic methods to find your invariance.
The advantage is that you will get some new type of solutions. If you consider, for example, group and invariant solutions, so yeah, in this case system, it is possible to show that you will consider this type of solutions, invariant solutions, in case as differential constraint. Differential constraints is just using coefficients of generator. So, and then system is involutive. Even more if you consider so-called Lie-Backlund transformation, then, hello? Hello?
Да-да.
Yes, we can hear you.
Something happens that I cannot see Zoom. Okay. Then in this case, if you consider such kind of solutions, so then then it's possible to show also that they compose system differential constraints which are involutive. To answer that system will be involutive from beginning, it's not possible. So it is necessary to do first to construct determinant equations. Like in group analysis, you have to solve determinant equations. So not big difference. Only one difference that in this case, determinant equations in case of group analysis, they are linear. Here, they are non-linear. So, but you need to solve determinant equations in any case. And if you are lucky, such that system will be involutive, so then you can get some new type of solutions which are not cannot be obtained by method of group analysis. Except, as I told, this is a problem was set by Ovsyannikov and Yanenko. What are relations between partial invariant solutions and differential constraints? There are no general answer on this question. So there are examples, and in particular here I talked about example that they can be described in gas dynamics. This type of solutions can be described as by differential constraints and also as partial invariant solution, but in different space. So it's necessary to prolong system of equations, and then we will get such kind of solution.
Next, please.
I don't know why I have no Zoom.
You have it if you go down on your laptop and look for the icon. You know, if you just move your hand.
I want to say that it disappears. My Zoom screen disappeared, and I have to sign in again. And so I don't know. I just maybe I will stop sharing. Oh, okay, I came now.
Sergey, did you use computer program?
Oh, of course, I am fan of reduce.
Oh, but only for internet, how to say, промежуточные calculation.
Oh, yeah, sure. For intermediate calculations, yeah.
But you didn't use a Maple program where
No, I don't use because a long time ago, in the beginning of 90s, I read one review where it was compared several methods. It was compared Mathematica, Maple, and reduce and MuMath and something else. So it was written that if you know reduce, you don't need to study other computer programs. And for Maple, I have some answers from, I don't want to say whom, that Maple gives result in any case, and you don't know what is given. So even it cannot solve, but it gives result. So this is like a black box. I don't know what is inside, but in reduce, I know what I'm doing.
Thank you. Other
Natalia,
questions, please?
I think Natalia has question.
Okay.
Natalia Manganarov.
Yeah,
Sure.
Sergey,
I'm glad to see you here. Long time.
long time. Yeah, you are right. Just a comment. In the case of the 2 times 2 homogeneous system, you showed us written in Riemann variables. If I understood well, you succeed in solving in general the compatibility conditions. It is right?
Yeah, this is differential constraint. Yeah, we have that system written in Riemann invariants, and then
Yeah.
I allow for differential constraints also to include independent variables. And this gives extension. And then, for example, this extension allows to construct solution of Cauchy problem, any Cauchy problem.
Right. Just to give you that Carmela Curro and myself, we tried a similar approach for the same system, and we used also autograph transformation for solving the system. In such a case, such approach was useful for studying nonlinear wave interaction, and also for solving Riemann problems and generalized Riemann problems. So I think your approach, it is very useful for such a kind of wave problems.
Thank you, Natalia. I know your papers, so I follow your results. Thank you.
Next question, please. Any remarks? In this case, we must game over. Thank you very much for your report.
Thank you to everybody. Thank you very much for participants. I'm glad to see many friends.
Okay, thank you very much once more. Next time, Salavat Valerievich Khabirov. Goodbye, my friends.
Bye-bye.
Goodbye. Thank you so much. Bye-bye.
Goodbye. Goodbye.
Goodbye. See you tomorrow.
Thank you, sir, for nice lecture. Thank you.
Пока, Сереж.
Пока. Ну, остались только
Голос.
мы, да?
Сереж, ты говорила,
Я
у меня
не знаю,
голос.
где тут нажимать ничего.
Сереж, ты
I'm
говорила, у меня
excited.
голос сел, а у меня голос сел. Ты говорила, у меня голос сел.